Now we're moving on to the O of the SOLID acronym, which stands for the open-closed principle. So if you remember from our previous lesson when we were talking about the single responsibility principle, we started with an invoice class that knew how to do some basic calculations around itself, but originally was printing some information about itself out, which started to violate that single responsibility principle. So we extracted it into its own class whose sole purpose or responsibility is around the printing logic of a particular invoice. So that's pretty nice. And then we needed to start to do some validation logic around our invoice. So we needed some way to be able to say, well, we shouldn't be able to set the subtotal or have the subtotal be less than 0, or maybe the tax rate shouldn't be less than 0, and then ultimately these shouldn't be less than 0, and things along that nature. So our first initial gut was to add some validation logic within our invoice class, but we decided, you know what, no, we shouldn't be doing that because that's going to violate, once again, the single responsibility principle. Let's extract that logic somewhere else. So we created a new invoice validator class who knows how to validate the logic, or has the logic to validate a particular invoice. And as you can see, we started to put these rules in here to say, okay, well, if a subtotal is less than 0, then we're going to return false out of our validate method. And you can get as sophisticated in here as you'd like, but I just wanted to get something simply completed within here. So we'll return false if it's not valid, and we'll return true if it is. So the next thing we're going to check if the subtotal is not less than 0 is we're going to check the tax rate. If that is less than 0, then we're once again going to return false again. And if we make it through all of these gates, then we're going to return true. Now, if we start to look at the logic this way, what's going to happen? Well, let's say that we introduce another way to validate this particular invoice. Maybe we want to create a validation step that's going to make sure that the calculate tax method returns something that's greater than or equal to 0, and same for the calculate total method of our invoice. So we want to be able to make sure that all of this is valid. Well, writing it in such a way where we're doing it like this, making individual gates a number of if statements or a switch statement or something like that, every time we add a validation step, or something that's going to enhance this particular class or method, we're going to have to come in here and modify this validate method and put another if statement or whatever sort of construct we're using within here, and that in and of itself breaks the open-closed principle. So the open-closed principle really says that the class or the functionality that we're working with should be open to extension but closed to modification. What does that mean? That seems kind of contradictory. Well, in fact, all that means is that the class that you write, the functionality that you are writing, should be easily extended, or its functionality should be easily extendable without actually having to modify its code. So, as I mentioned in the previous lesson, we want to be able to get to a point where we write this code and we should never have to go in and change it. It should just be functional in and of itself, regardless of how the requirements change, or not how the requirements change, but regardless of how functionality enhancements come in the future, we should never have to modify this. So how do we get along those lines? How do we get to the point where we're actually able to do that without having to come in and modify this method? Well, we're going to have to refactor this a little bit. So what we're going to do is we're going to introduce a way to inject some of these validation rules or this validation logic into our class and then just be able to use them within this method. So we're going to come into our project here and we're going to introduce a class that's going to be called a validator. Now this validator class is going to be public, but it's also going to be abstract. So this is not going to be a class that you can create or instantiate directly. You have to use it as a base class for something else. So we're going to introduce in here an abstract method that's going to return a Boolean that's going to be called validate. And in our case, we're just going to take in an invoice because that's ultimately what our system is dealing with. So this means that any class that chooses to inherit from this validator class must implement this method in some way. So let's go ahead and start to do that now. So if you take a look back at our invoice validator, so let's go ahead and close invoice and invoice printer. If we take a look at this, one of the first things we're checking to see is if the subtotal is less than 0. And if it is, then we're going to break. So let's go ahead and create another class that's going to be called subtotal, or actually we'll call this invoice subtotal validator, which is once again going to be a public class, and we're going to have this implement or inherit from validator. So that means I'm going to have to give some functionality to this particular method, which means all we're going to do in here is we're going to check to see if my invoice.subtotal is less than 0, then we're going to return false. Save. So now, if we take a look at this, we know that this has a single responsibility. It's only supposed to come in and validate that an invoice subtotal is not less than 0. If it does pass that, then we'll simply return true. So we'll go ahead and save that. And then we'll go ahead and we'll create a couple more of these, and then I'll come back and I'll show you what we're ultimately left with. So here we are back again. Now I have my abstract class validator that has a single abstract method called validate, and I've created 4 different subclasses of this particular class. So I have my subtotal validator that's going to return whether or not the subtotal is greater than or equal to 0, because we don't want it to be negative. Same with the tax rate. We want to make sure that it's greater than or equal to 0. Then we have the tax, the tax validator, which is going to make sure that that calculate tax method returns something greater than or equal to 0. And then I also have the total validator, which is going to do the same thing for the calculate total method. So that all looks very nice. Now I can come back into my invoice validator and I can start to restructure the way that this is going to work. So what I'd like to do now is I would like to have a way to store any number of validators that are coming in to do any sort of validation on my invoice. So I'm going to create a private list of validators, and I'm going to save these here as underscore validators, and we're going to bring them in via a constructor. So I'm going to pass in a list of validators into my constructor here called validators, and we'll set my private variable equal to those that are being passed in, and we can save that. So now I can modify my validate method to run through all of these validators and return true if they all passed or false if one of them failed. So now I can come into my validate method and I can change this to say I want to return whether or not all of my validators, and I'm going to make sure that each one of them is calling the validate method on the invoice that is being passed in, and I'm simply going to return that. So now I'm saying that I want to make sure that all of my validators are returning true or are satisfying this condition to be true for this invoice that's passed in. So now if I pass in all of these validators and one of them fails this condition, then I'm going to return a false. But if they all pass, then I'm going to return a true. So now this particular implementation of my invoice validator is going to pass my open-closed principle because it's open for extension, because now I can add in additional validation checks on my invoice by passing them in as a member of this list of validators, and all I have to do is run through them in this manner. But I'm closed to having to modify it because if rules change or if the validators change, I don't have to change the implementation of my invoice validator class. It's going to stay closed to those types of modifications. So now that we have the first 2 solid principles taken care of, it's time to focus on the L, which is the Liskov substitution principle, and that's exactly what we're going to take a look at in the next lesson.